This is the final project for cost spatial analysis for urban and environmental planning. Our group is analyzing the demand of Seattle's parking conditions and current problems in order to forecast the future parking supply and demand better. To achieve this goal, we are developing an application named by Let's Go Parking, as the icon shows at the right bottom column. First, we conduct a research looking at Seattle. Seattle has 1.6 million parking spots. That's more than 2 spots for every person in the city. So why can't people find a spot? Since the study only looks at on-street parking, we're only focusing on the highest demands of parking areas. There are downtown areas around the University of Washington and in waterfront areas in close proximity of downtown. We can notice that the parking spaces are often fully occupied. This suggests that the supply is unevenly distributed. So our project is aiming at analysis the parking vacancy rate. This will help in 3 ways. First, where to find the parking place. Second, find a cheap place to park. Last, before you drive, maybe some destination is better getting there by public transportation. To achieve our goal, our app has 3 main functions. For those who are already in the place and in a hurry to park, they don't care how much it takes. It's just somewhere. For those who are trying to find a cheap place, not that urgent, our app will help them to find the most cost-effective place. Lastly, if you haven't gone to your destination yet, you can open up the app before you depart, just to decide whether to drive it or not. Now let's open up the app. First, enter the location and time period. The app gives you a list of all street parking addresses on record. Choose one that you are at and also the time period and how long do you want. Then the app gives you a clue by listing all necessary information, the spaces in total at the street, and the available places. If the available parking is not there, 0, go for it. If it is not, but exists someplace nearby, and you really want it, click on it. Once you see the options nearby, you can choose from them. The app will recommend you on the nearest one. You can click on every pink icon to see the availability as well. If you do want to find some cheap place and you have a little bit more time looking at the app, there is a map telling you the pricing. As I said, it is not always good to drive. It's a pain to find parking. Before you go, you could see the route first by entering the start and end points. The calculation give you a clue how many times it takes. Most time, driving is taking less time than public transportation. However, this is not the point of this function. It is designed to tell you about the difficulty of parking. If the 5-star difficulty at the place you want to go, then do not drive. It takes forever to park and doesn't worth it. Going back to the fundamental part of the project, we build up a model based on the training dataset to predict the test dataset. Here we use data points from 2014 to 17 and run the regression model on the 20 neighborhoods. Our dependent variable is binary. The vacancy rate is a yes or a no. We choose to use multinomial logistics model in this case. Our model is built on predictors listed here. The most important pattern we are trying to find will be using lags and do spatial and temporal correlations, maybe daily lags as well as hourly lags. Here is the results. We can see that the mean predicted likelihood of a spot being full, the average residual of that prediction, and the actual percentage of a spot in that group by study area and by time of day. Since true positive and true negative add up to 70, so our model has a 70% accuracy. Our predicted value average out to the same as our observed value for all hours and study areas. That is good. It tells us that the model is not biased towards under or over predicting accuracy in any of these data subsets. That said, the size of the absolute residual does vary substantially over time and space, which tells us that our model is better at predicting for some of these groups than others. To improve the project, the app could include users to report errors. Also, the regression model could include more useful predictive variables by updating it on a yearly basis. That is all. Thank you.